We're at the IAS meeting in Kuala Lumpur with Jonah Sacha, who is from OHSU and Oregon Health Sciences University, which is in my neighborhood, Portland, Oregon. You live the other side of the mountain. You live in Beaverton. I live in Southeast. But we're nonetheless come a long way to talk on, right here at the conference about the work that you're doing. And you did win an award at the pre-meeting that they had there at one of the hotels, off-site meeting. That was going to talk about the cure. So, and you were required to stay to that. So we may ask you for a few questions on that as well. Sure. But I do appreciate you taking the time and the work that you did. Jonah, what was the work that you did that actually caused you to achieve or to acquire that award?
Sure. So thank you for the invitation. Mm-hmm. I'm always happy to talk about what I'm doing because I love doing research quite a bit. So what we did, sort of step outside the box for this project, and we decided to go after the latent reservoir of HIV. As you know, we've come a long way with the antiretroviral medication, which suppresses the viral loads but is not curative. And so there's a big push in the field of HIV research for, can we define where the virus is hiding during our antiretroviral therapy? And then can we eliminate that? And we are examining the reservoir that's present in macrophages, which is one of the major targets of the virus. And most people focus, and rightly so, on CD4 T cells because they're the major target of the virus, but macrophages are also very important. They are located in every tissue in the body, including the brain, and it's known that antiretroviral medications cannot reach them very well in the tissues, and also they act very differently in these cells than they do in CD4 T cells. So we're trying to define that reservoir and then find a way to pharmacologically deplete those cells that are latently infected with HIV.
So the work that you're doing, where are you in the scheme of the process of the work that you're doing? How much of the distance down the road have you gone so far?
We are pretty much at the start of the adventure. So the award is a creative and novel idea in HIV research, and at this stage it is very much an idea. We're actually just submitting the manuscript today describing the initial procedure, which is we've come up with a way which we can deplete these macrophages in our experimental model. And so we have proof of principle that we can do this, and now we can actually really investigate what the role of these cells truly is in latent HIV infection.
So the work that you're doing is going to be likely a piece of what we now consider the work that's being done collectively as the cure.
Yes.
Would you say that? And so I think it was you that mentioned that you were mandated to be at the meeting all day, the first 2 days. So how was the meeting? I mean, this is embargoed, so don't worry about any embargo stuff. But I mean, did you feel like it was, just explain what your take on it was.
Sure. It's exciting to be part of something because this is a new push. For a long time in the field of HIV research, the word cure was a taboo. No one really talked about it. And since the Berlin patient and now the Mississippi toddler, there's been a real push towards cure research. And so it's exciting for me. This is the first time as a scientist I've ever taken part in a conference whereby it's actually focused on cure. So it's a very exciting time for research.
So I think a couple of people, including I think Carl Diefenbach, was saying that we maybe shouldn't use the term cure, that we should use something else. And towards a cure we're using, because we don't want to give people the wrong message that this is like, simple, easy, this is it and that. Because it's so many pieces, so much that we have to learn. I was even talking to Steve Deeks about the need for, the possible need for more assays to be validated that might help us understand what we're learning. But so I think that, like you say, it's a very early part of this process. But nonetheless, so the meeting that you attended and some of the presentations that were given there were interesting and exciting.
Yeah, absolutely. There's some really new innovative ideas out there. But I don't want to call out any particular ones because I'm not sure if I should. Some of this research is not published, but there again, and you bring up a great point that yes, we should be careful with the word cure. I sort of think of it like the fabled Northwest Passage. We'll get there eventually, but it's going to take a very, very long time.
And we don't know all of what's going to be involved in it. And we do know some of it, but you're working on what you think is a piece of it.
Yes.
And if it is, it's a great, move in the right direction. So what are the other things that you told me before we started this that you're working on 3 areas of work?
Mm-hmm.
Can you describe briefly each of those areas?
Sure. So one of them is what I received this award for, and that's this idea of going after the macrophage reservoir, because macrophages are a really understudied cell type. The reason being is because they're very low in frequency, but they're critical to every biological process you can think of. Wound healing, tissue development and maintenance, neurological function. They're involved in everything. And so they're very critical to study, but they're also very difficult to study. So that's sort of the idea for that phase of the research, is to determine what macrophages are doing in maintaining the HIV latent reservoir. The second thing we're doing is very exciting. Let's work with Dr. Lewis Picker. He has come up with this idea of using cytomegalovirus, or CMV, as a vaccine vector. And this is actually the reason I came to OHSU. This is probably one of the most innovative ideas out there right now. We just published a paper together in Science where we described a type of immune response elicited by the CMV vaccine that breaks all the rules of immunology. It's absolutely fascinating.
Were you at the CROI?
I was not, no.
Oh, yeah, well, that was pretty. I mean, the last presentation, Steve was there as well as a number of other people. But I think that's what caused a lot of people to just stay late.
Yes,
Yeah.
it's absolutely fascinating.
Yeah.
At the time I was teaching immunology at the med school, and as I'm teaching, this dogma of this is how the immune system works, and the whole time within our labs we're doing this research that's breaking all the rules and basically taking all the paradigms and snapping them.
Yeah.
And that's the most exciting thing you can ever have as a scientist.
This is what we know now, but stay tuned, it's going to change.
Yes, exactly.
So you came to OHSU because of the dynamics and the work that was being done, which was really amazing. Now, that's what we're trying to instill in the people that are viewing this program, who are potentially thinking of getting into the field of medicine or research science and so forth. Basic science, clinical science. And to me, basic science has been the most exciting thing that I've watched with Dr. Coffin, and we were just talking about others in San Francisco, like Jay Levy and so forth. There's some real amazing gentlemen that have done the work over the years and been there and kind of are way out ahead of the field early on and still doing good work today. So we look forward to what you're going to be doing, and we'll be watching. And I think that maybe there'll be a time when we'll look back on this and say, what's the beginning?
That would be fantastic, and thank you for the kind words.
Yeah. Well, thank you so much. I appreciate for being here.
Thank you.
Okay.